Our session is entitled Next Generation TV Part 1, Not Your Father's Television. Our first speaker is Mark Corll from Triveni Digital USA, and the topic that he's speaking on is the broadcast guide to surviving the Repack, channel sharing, and upcoming transition to ATSC 3.0.
Good afternoon, and hopefully everybody had a good break for lunch. So this is a very tactical presentation about where we are now and where we're going to be in the next, well, maybe year or two, with an ongoing look at moving into 3.0. All right, so the first thing I want to talk about are the channel sharing PSIP requirements. You'll all remember PSIP. It's a required standard for broadcast. The second thing I want to talk about is station architecture and implementation options there, and practical considerations and best practices when doing channel sharing and things of that nature, and a look ahead at the 3.0 options, which is sort of where I'm really focused on right now. So we'll get through these other things though as a reminder and look at how to do channel sharing. So some of the channel sharing goals is basically to combine two or more over-the-air broadcasts into a single 6 megahertz frequency. So for example, a local PBS or NBC station trying to put themselves on one tower. So what we want to do in that, at the same time we're putting them on the same frequency, is to preserve the station branding. So that includes the major number, the name, so the 7 characters that are in the BCT, the EPG information, which is promotional, and to, at the same time, optimize bandwidth, quality, and workflow. So a quick reminder or a quick review of PSIP and the PSI linkages. PSI, if you remember, is what's in the MPEG-2 transport, the patent PMT. And then PSIP, there's one table in PSIP, the BCT, that then also refers back to information that's in the patent PMT. So in other words, the BCT gives the notion of the major and minor numbers on top of what is normally the TSID in the PAT, and then the PMT is linked off of that. In this example, there's only one PMT. Normally there's 2 or 3, perhaps 4 for every service that's in the broadcast. So then we look at the PSIP linkages, and for those of you familiar with PSIP, you'll remember that this is fairly complicated. There's a lot of linkages, a lot of things hooked together. I remember doing a presentation a long time ago about the complexities of PSIP at NAB one year, and had a slide even more convoluted than this one, talking about all the different tables, how they were all cross-linked, and this is a simplification of that. So there's the system timetable, the master guide table, and that points to all the other tables, which is all those lines there, and then the virtual channel table, which tells you the major and minor numbers of your services, and even services that aren't in this broadcast. You can actually refer to services outside the broadcast if you like, on different TSIDs. And then within those are the event information table, the EITs, and you have to broadcast at least 4 of those. They're in 3-hour blocks, so 4 of those would represent a 12-hour segment of promotional information, or at least what's on at this time, the program information. And above and beyond that, you can send extended text, which descriptions and other type of information. So here's an example, sort of where we are now. We've got 2 stations on physical channel 41 and physical channel 29. They have different TSIDs. One's broadcasting 10.1, 10.2, 10-3, WAAA in this example. And similarly, we've got 6-1, which is WBBDT. So actually the letters up here are important because you can actually only carry 7 in PSIP right now. So this is the case where you have a duopoly, and in this case you'd actually have 2 transmitters, but essentially it's owned and operated by the same broadcast, so they're all WAAA on 2 different frequencies, and these would count up 10.1, 2, 3, and then over to the other TSID, we'd have 4, 5, and 6. And both sides may be actually sending EPG data, advertising the other. As I mentioned before, you can actually, in the VCT, you can refer to other services, and also you can send EITs for both, so you can cross-promote two different frequencies. So now we have multiple major numbers in two stations. So in the first one, it's channel 41, it's the same. Channel 29 though, it's switched over, and now there's a 26-1 that's carrying something entirely different and branded differently. That's certainly possible with PSIP. So in a channel sharing case, we have the original that we had showed in previous slides, and now we're going to take those and combine them into a single channel. And in this case, you end up with two channels for WAAA. It's really hard to say. I don't know why we use this. And channel 2 for WAAA, and two services for WBBB. And you'll note that both stations lost a minor, a dot number. So they both lost a .3 in this case. And that just is because with the compression as it is, you probably can't get all 6 of them onto one, presuming that the DTs are actually HD. So here's what's the important bits about PSI and PSIP merging. In the PSI, you have to have unique PMT PIDs. This just, in some respects, goes without saying, but many, when you've got setups such that you've got different encoders and different systems working, trying to merge those together, you have to remember to change the program numbers, the PMTs, and all of the PIDs that they're running on to make sure that you have a completely laid out stream. And each elementary stream also has to have unique PIDs. This seems to go without saying if you understand transport streams, but you'd be surprised how many times we'll go, just somebody saying things aren't working, and we'll go and look at it, and they basically just didn't bother to change the PID numbers on, when they put two services together, and all of a sudden nothing's working. So it's just one of the things to remember. In PSIP, you've got a single TSID for the host station, and everybody all the branding still has to maintain the major and minor numbers, and you have to have unique source IDs in the VCT. Those are essentially, each service has its own ID, and that cross-links all of the tables. So that's what the source ID does. And you have to make sure, and this is one of the tricky ones also, you'll see this happen all the time, the service location descriptor has to match all the PSI in the current transport. That can be very, very tricky. And you have to have unique EIT and ETT PIDs. So that's the first part of the channel sharing PSIP requirements. The second bit we're going to talk about is station architecture implementation options. So this is what we call a PSIP aware MUX. So in this case, you'd have you'd have a guest station that's sending out, basically it has its own PSIP generator. It's sending out PSIP for channel 2 and basically on a separate channel. And then you have the host station. So the host station is essentially operating as it always has. It may limit some of the capabilities it had. It may drop a dot channel or a dot service, but it's basically going to be sending out and behaving the same way. But in this case, we have a multiplexer that's aware of the second PSIP source and can merge the two. By merge, I mean it just keeps the tables separately. So they're both putting out the same thing, and that would be, the MUX has to merge all of that information. So the PSIP is groomed at the MUX. So everything ends up being in the PSIP that I just described in the previous slide. So in this case, this is master PSIP generation at the host. So in this case, there's a PSIP generator, but in this situation, the guest station or stations simply supply their information and control and manage what EIT information and ETT information is being presented. So they still have their traffic automation. The listing information comes in for those services. And if you remember on the previous slide, we had WBBB. That listing information would come in for that service and just be created and generated inside one PSIP generator. And then both of those major channel numbers, 1 and 2, would go out out of that same PSIP generator. So there's one source of PSIP in this case. And the back end here, even on the previous slide, just shows basically a redundant multiplexing system, if you want that. And most people have redundant, at least cold or cold spares. So this is also something that we've been deploying, which is cloud-based PSIP generation. So in this case, essentially the PSIP server is in the cloud, or the software that's implementing the PSIP generator is in the cloud. It's essentially doing the same thing that it did in the single station mode, but in this case it goes through, and the guest stations are still supplying information to it and controlling what they're setting up in terms of schedules, but they all end up going up to the cloud. They all are basically communicating with something essentially sitting in the cloud. And then that communicates back to the muxes at the station where the transmitter is, or however it's going to the STL. One thing I should point out here, and there's been a thing called SLA. Basically the system really wants to, you really want to basically monitor for when services, your agreements and service agreements and the licensing agreements you've come up with, systems are being built now that allow you to basically verify or characterize how the two services are working together. So most folks will, when they do a joint channel share like this, they'll be pretty easy about it, but there still are systems that break, right? So still sometimes if you've got the multiplexers or encoders set up in such a way, it's occasionally the case that things might actually exceed their what bandwidth limitations you've had set for them. And you want to know that, because over time that can cause degradation, it can cause packet drops, it can cause all kinds of problems. And so you really do need to monitor that, make sure that everything is being done the way you think it should be done. And probably, well, in certain situations, we're working on systems at this point where you have an ability to set a schedule. So for example, one can imagine, say a PBS station wants more bandwidth during the day, and a regular broadcaster may want it during prime time, or vice versa. However that agreement works out, you still want to be able to do both of those simultaneously and monitor for that as well. So I thought it'd be useful to create or have some practical considerations or best practices when doing all of this. So the early market rollout of PSIP was confusing. As I mentioned before, I did a presentation, I think probably almost 20 years now ago, talking about PSIP, and people were really confused and really didn't know what was going on and didn't understand it at all. And it was mandated after the initial rollout. So when HD first came out, PSIP was brought on later and then mandated later. And a lot of receivers were using the RF channel number and program number. So in other words, they were using the PSI information. And it turns out that that's still kind of happening. There's still software out there in receivers that doesn't really behave well with PSIP. So sometimes they prioritize the RF channel over the major number for tuning. And we've run into problems with these receivers even now, where folks will have a major number that matches a local frequency channel number, and it won't tune. You try to tune to your channel 33, for example, and it'll jump over to channel 3. That is happening, or has happened, within the last couple of years, turns out. So try to avoid using a major number that's equal to a local RF channel in your viewing area, because some receivers, and I will say that this happened with receivers that had their software updated. So it wasn't the case necessarily that it was an old receiver that didn't know what it was doing. Somebody got new firmware and it broke. So this is something you want to pay attention to. So service level agreement verification is always a good idea. probably want to have that. The other thing that we're promoting is Huffman coding for the text. Many of you may not know, but PSIP actually allows the text to be compressed using a Huffman coding scheme that's in the standard, has been in the standard for a very, very long time from the very beginning. So that actually helps reduce the bandwidth. So if you are actually putting out multiple EITs, multiple ETTs, you can do that. You can turn on the Huffman encoding, you'll actually get a lot better bandwidth usage. Adjust the EITs and ETT tables to follow the A69 recommended practice that was done. Optimize the number of EITs, and this is key. You may want to vary that per virtual channel. So there might be the case where you have a .1 or a .2 that you're not, or a .2 that you're not necessarily promoting as heavily as you would be your .1, and you want to change the number of EITs and ETTs in that, and you may even drop the ETTs. ETTs are not required, so you could actually drop the ETTs, the descriptional information. And to that point, the descriptive information to what is absolutely necessary, limit that descriptive information. A lot of receivers, the guides aren't as, shall we say, populated as they could be, and so often there's just a couple of lines of text, if that. Often you don't even get the descriptional information on most receivers. You get maybe a line of text, a quick description, a few, tens of characters, and that's it. I hate to say that, being a broadcast, somebody who develops PSIP generators or has been developing PSIP generators for years, but that's just the way it is. It's just the way the guides are at this point. So a bit of a look ahead to ATSC 3 options. One of the things that I'm actually the chair of is the ATSC 3.0 transition. It's being run by TG1, if everybody knows that. So we're actually exploring signaling extensions to ease the transition. We're working on things that would allow broadcasters to send out information, that it would allow newer receivers, or receivers coming off the shelf, to be able to track and follow what's happening to channels as they're merged, as they're repacked. So we could put out a schedule and provide perhaps a regional channel map for both in OTA over-the-air broadcast. The information would come over the air, or we can do it over the top. So have a service that allows that to happen. This will probably also be promoted or put in as an addendum to 3.0. That's one of the things we're talking about as well. So we could actually send out information, because it's very likely that even after some stations have transitioned to 3.0, or there's things you can see a long-term where people will be moving, folks will be moving from ATSC 1.0 to 3.0, moving from 3.0 to new transmitters, new channels. And so we really want to help receivers in this case. We're not going to basically tell receivers that it's happening, or in other words, we're not going to send out signaling that says, oh, you need to rescan now. That's not going to happen, so that for the obvious reasons, I think, because nobody wants all of a sudden your television going into a rescan mode at any time. They at least like to be able to control that to a degree. So, we'll have information like that in the stream, so that the receivers will have enough information to tell the user that, hey, stuff is changing around, your favorite channel might be moving, what do you want me to do about it? We're also looking into enhanced codec support. So one of the things I mentioned earlier was that if you start merging these into a sharing situation, you're losing a few dot services perhaps, because the encoding isn't there. Well, if we weren't constrained by MPEG-2 video, then perhaps you could do more. So there are experiments going on there. ATSC is not promoting those in any way, but we are watching them in detail and see what happens with those. So you can expect recommendations, or perhaps even standards to, new standards to be coming out early next year. So the last thing I wanted to talk about was essentially a hybrid delivery starter kit. So this is the case where you have 3.0 or 1.0 equipment in place, and most manufacturers now, including Triveni, are enabling 3.0 capabilities on their devices. So for example, certainly we can do signaling and announcement that complies with the 3.0 standards that are currently coming out. But similarly, so can the encoder manufacturers. Most encoder manufacturers, with a simple turn of the license key, can start outputting HEVC. And so we've seen this in the field. So what this is showing is that essentially at the top, you have an OTT packager, you've got an encoder, and it turns out that in ATSC, in most OTT packagers, or at least all the ones I'm familiar with, will actually emit an MPEG-2 transport. At the same time, they'll emit dash ISO-BMFF files, or even MPUs for MMT. So at the same point, you can take both of those and feed different stacks, different broadcast stacks. So in the case of the MPEG transport, and as well, you can feed over the air with the same packager to an origin server. And in the MPEG transport case, that simply goes into an MPEG transport MUX. PSIP is supplied by the PSIP generator, just as it would be now. And that feeds into the ATSC 1.0 stack for emission. Similarly, going into the route MMT transport capability there, down below the OTT packager, we have signaling and announcement going into that. That would be 3.0 A331, if you want to know the standard number, going into that, and then that emitting essentially the ATSC 3.0 transport. ATSC 3.0 transport is essentially IP. So that's what comes out. It's a bunch of IP packets. That goes into a broadcast gateway that then puts the next two layers on it and emits that, ready to be placed on the RF. So these systems are actually being deployed today. We have had a system like this running at WRAL for quite a while, and it's being deployed in other places as well. And you can sort of pick and choose different items here. So 3.0 experimentally is quite well along, and so this is actually available in a small one rack unit set of units. I think it's about 6 RU, maybe 8 RU now. Oh, and I shouldn't neglect the emergency alert receiver mechanism that goes into the system too. And just like before, it will also be generated for both 1.0 and 3.0 simultaneously in the system, if it's licensed for that. Okay, that's the end of the presentation. Any questions? Looks like somebody's coming up to the mic.
Simulcast requirement of ATSC 1 and ATSC 3. What discussions have been had with the Consumer Electronics Association to differentiate between a consumer putting in 2.1 and selecting ATSC 1 versus ATSC 3? How does the consumer differentiate and select between the two services when the channel assignment is going to be very similar in terms of the virtual channel?
Right. So one of the things in that signaling that I talked about for the transition, one of the things we're putting there is what we considered a preferred alternative. So a broadcast, a 2.1 on 1.0 will essentially say, oh, by the way, there's an HEVC version of this over here, and point to someplace else, and whether it be 3.0 or something of that nature. And that will allow you to, and it could even do it 1.0 to 1.0 for that matter. It could go from SD to HD.
And that would work the same way if they are not the same, the two services?
Yeah.
Okay.
Yeah, so for example, if you chose not to use the same major and minor numbers, or they were different for some reason, or you just used a different minor number, you could point to that other one. And so essentially you just have to ID the other service that you would consider preferred. Now, preferred is whatever you feel is
Electronic
preferred.
program guide in the set, how will that be flagged? Has there been any
Well,
indications?
now you're moving into CE manufacturing.
That's what I said. Have there been any discussions with them to discuss how it
so-
will be identified to the consumer?
I don't know how they would do it. One would expect that it would do, you can see this behavior in cable plants now, right? And you set a setting that say prefer HD, and it would just go there automatically, or prefer 4K, and it would zip over there automatically. I don't know how they would represent it on the UI, but it would know what the encoding format is, and that would be part of the promotional information. So at the very least, we could do it in the ESG using promotional information in there. That's a quick and dirty way of doing it, just put the text in. But you'd want something a little bit more context sensitive, I would think. So that we've added that into it as well.
Okay, good. I'm told the FCC report and order will be out at 7 p.m. Eastern Standard Time, or Eastern Daylight Time, so we can expect it very shortly.
Oh, cool. Any other questions? Okay, thanks.